Okay, so let's take a look at division of polynomials. Terms, the front term is the divisor. The term underneath is the dividend. The top, where you're looking to fill that in, that's your answer, and that's the quotient. And then what's ever left over is your remainder. So when we divide, we're not going to try to find a decimal answer. We're just going to stop after we divide it in and find our remainder. So 17 divided by 5 is 3. You multiply the 3 times the 5, and that's 15, and then we subtract to find our remainder. So it would be 2. Okay? Now, an important thing is you need to know how to put these numbers back together. So we want to change this 17 in using the 5 and the 3 and the 2. We want to be able to make 17. So if you multiply the divisor times the quotient, add the remainder, that would equal the 17. So that's always going to be the case. The dividend, which is going to kind of be the polynomial that we're dividing something by. The polynomial is equal to the divisor times the quotient plus the remainder. So let's practice here. Let's go through the process a couple times here on a bigger problem. So 12 doesn't go into 3. 12 goes into 37 about 3 times. So 3 times the entire divisor is 36. Now here, there's an issue here because the way I divide is I put a minus here and I subtract the 36 from 37. So we're clearly not going to put a 73 here by adding them. We're going to switch this 36 to a negative 36, and it's negative 36 plus 37 is 1. So switch this term and add it to the top above, to the term above. Bring the 5 down and begin again. So 12 goes into 15 once. The 1 times the 12. So the 1 times the entire divisor. And then again, we switch this from a 12 to a negative 12, and we add. And then 12 divides into 34 about 2 times. And then subtract, and we have a remainder of 10. Okay? So 12 times 312 plus 10 would equal 3,754. So now we're going to do the same thing with variables. So what I'm going to do is I'm going to remind us the steps by redoing that problem that we just had there. So I'm going to rewrite it. If you want to do this with me, you can. But I'm going to divide 12 into 3754. And I'm going to divide x minus 5 into x cubed minus 9x squared plus 15x. Okay. Now here's the deal. Whatever you put in the answer, it's got to be in the right positions. And even below this when you do some work. This is the x cubed column, this is the x squared column, this is the x column, and this is the constant column. Just remember that when you do your division. So 12 divides into 37 3 times. So we're looking for an expression, a variable expression, a term that we can put in the answer, a quotient. Those can be variables. So here's what you do. You divide the front term of x cubed by the front term of the divisor, and that expression is what goes in your quotient. Okay, so x cubed divided by x is x squared, so use your laws of exponents, subtract. So that's what you put right here. So you're on your way. So again, going over to the numeric division, I'm going to multiply 3 times the 12, the entire divisor. So I'm going to take the x squared times the entire divisor. So it'd be x cubed minus 5x squared. Now I'm going to subtract these two, but then again, I put the sign here. I switch this from a 36 to a negative 36, and then I add them. That'd be 1. So I'm going to do the same thing to both of these terms. I don't want to add these together. I want to subtract them. So I'm going to switch this, and I'm going to add it to that. I'm going to switch this to a positive 5x and add it to that. That's how you subtract. So the problem here is negative 9x minus a negative 5x squared. So we're taking the top term and we're subtracting that bottom term, and we're doing that by switching it to, we're adding the opposite of the negative 5x squared to that. So that is negative 4x squared. So going over here, you bring this number down and you divide again. Over here, you bring the next term down and divide again. So we know this is 1. Over here, we divide the front term of what we're working with, because these are gone. They added up to nothing, so this is all that's left. We divide that negative 4x squared by x. So it'd be a negative 4, and x squared divided by x is x. So we got a minus 4x in our quotient. This guy divided by this guy. So now at this point we had to multiply just the 1 times the 12. So over here we're going to just take the 4x, the negative 4x times the whole divisor. So it's negative 4x. We're done with the x squared. That's there. Negative 4x times x is negative 4x squared. Negative 4x times negative 5 is positive 20x. Now we subtract. Switch the sign. I'm going to switch that sign and add. So I'm going to switch this sign and add. So I don't want to add right now. I have to switch the sign and add. If I switch the sign, that positive 4x and negative 4x is gone. And then I take 15x and I subtract the 20x from it. So that's negative 5x. Bring the 4 down. Bring the 25 down. Twelve divides into 34 2 times. All right, what is going to be the term in the constant? Divide the front term by the front term, and that's negative 5x divided by x. That's negative 5. Finishing it up over here, multiply the 2 times the entire divisor. So multiply the negative 5 times the entire divisor. The negative 5. So it'd be negative 5x plus 25. Subtract, and that's your remainder. Subtract. And again, how do we subtract? By switching the sign and adding. So add these together now after you switch the sign. That's 0. Switch those, and that's 0. So here in this case, we have a remainder of 0. Divides it evenly. Okay. So let's not do the problem above it. Now the only thing that we could do is talk about what happens when there is no x squared or x term. So if we were dividing that, it would be x to the 4th plus 0x cubed minus 2x squared plus 0x plus 3. Maybe we should do this one. Let's try this one. I'll give you a chance to write it down. x to the fourth column, x to the third, x to the second, x and 3. So x to the fourth divided by x is x to the third. Now we multiply x to the third times the entire divisor. X to the fourth plus 2x cubed. I'll give you a chance to think about what the next step is, but it's going to involve switching some signs. So I got to subtract this from this by switching it to its opposite and adding, switching this to its opposite and adding. So that's 0 when they add together. This is negative 2x cubed when you add together. Bring down the negative 2x squared. And now we need something in the x squared column in our answer. So the front term divided by the front term would be a negative 2x squared. So now again, we take this term times the entire divisor. Negative 2x cubed minus 4x squared. We have to subtract these now. So this is going to be a 0 when I subtract them by switching the sign and adding, switching the sign and adding. So it was negative 2x squared minus a negative 4x squared. So that's negative 2x squared plus 4x squared. Bring down the 0x. Divide the front term by the front term. 2x. Subtract these two by switching the sign. I'm just highlighting that with a different color. Switching the sign and adding. So add those together, positive, negative, opposites are done, and then that would be minus 4x. Bring down the 3, and we have one step left. Divide the front term by the front term to figure out what your constant is. That's negative 4. And then you multiply the negative 4 times the divisor, the entire divisor, and you have a remainder of 11. Now, one thing we didn't do is we didn't rewrite this in terms of the division, the quotient, and the remainder. So I'm going to do that here. So I'm going to say that x to the fourth minus 2x squared plus 3, I'm just going to leave out those zeros for a second, is equal to x plus 2 times the divisor times the quotient plus the remainder. That's another name for this, broken up a little bit. So that is division. Now, we can do, and this is actually synthetic here, we can do the same thing that we just did by using something called synthetic division. So when we do synthetic division, kind of a little bit different. We're not going to use any variables. So what we're going to put in this position is we're going to put the 0 of the divisor. So the divisor is x minus 3, so the 0 of that is just going to be 3. So you look at the divisor and you find the value, so it's really going to be the opposite of the minus 3 there. Put that in there, and then you divide into the quotient. Now the quotient, you write the coefficients down. So that's 4x to the fourth. X to the third is a 0, x to the third. There's nothing. 0x to the second, there's nothing. a negative 2x, and a 5. Now, what I want you to do is I want you to watch me do it. I don't want you to do anything because I'll do it all over again. I just want you to watch. So here's the steps. The first coefficient comes down. That's the only one that comes straight down. Okay? Now what you're going to do is you're going to multiply that 0 of the divisor times that number. And that would be 12. You move it over here. Now everything after this is going to be the same. You're going to add the two numbers that are vertical to one another. So that's an easy add. That's 12. And then you're going to multiply 3 times 12. And that's 36. You're going to do add these. That's an easy one. And now you're going to multiply. So it's always add and then multiply. Add and multiply. So that would be 108. Numbers are a little bit big here. Won't always be that big. Now we add. Now we multiply. And that would be 318. And then we add. And that's your remainder. So I always circle that remainder. That's your remainder. So now we got to figure out what is the expression. So like if you take an x to the 4th divided by an x, you should get an x to the 3rd. Well, here's what you do. This is your constant. This is your remainder. That's not your constant. That's your constant of your quotient. This is your x term. This is your x squared term. And this is your x cubed term. So this guy divided by this is 4x to the 3rd plus 12x squared plus 36x plus 106 with the remainder of 323. Okay, so let's try it again. Remember, this is the divisor. This is the 0 of the divisor. First step is the only one that's different, is this first number gets brought straight down into the quotient. So this is the quotient's underneath now instead of on top. Now we multiply and add. We multiply the 3 times the 12. We add the vertical numbers. Now we're done with these, so we don't ignore these. Take 3 times 36. 106. Add the vertical ones. Now ignore the first 3 terms because you're done with those. Now take the 3 times the 106. And constant x, x squared, x cubed. Okay? So you do this one. Remember to put your zeros in for the missing terms. One, x to the 7th, 0x to the 3rd, 0x squared, 0x, and a constant of 2. One. Bring it straight down. Now multiply, add, multiply, add, multiply, add. Multiply, add, multiply, add. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, kind of a big number, it's going to be 1,620, and that would be a remainder of 1,622. Constant, x, x squared, x cubed, x to the 4th, x to the 5th, x to the 6th. Okay, so what we're going to do is we're going to talk about something called the remainder theorem, and then we're done. So the remainder theorem is going to be determined by the relationship between these things here. So I'm going to call this f of x. So using the division algorithm, f of x, the dividend, is equal to the quotient here times the divisor. So x minus 6, or x minus c, we have a 0 of c, we have a factor of x minus c, so it's divisor times quotient plus remainder. So now the question is, what is f of c? What would you get out if you plugged in c into f of x? Well, f of x is equal to this, factor times this plus that. So let's put this c right in there, and there, and there, and there's no x to put it in over there, so we'll see what happens. So f of c equals c minus c, which is 0, times q of c plus r. So f of c equals 0 times anything is 0 plus r equals r. So this is the remainder theorem. F of c equals r when you're doing division. So you're wondering what that does for you. Okay, so let's go to the next one. Next page, and we'll get through this and we'll be done. So my question is, what is f of negative 1? Well, f of negative 1 is equal to the remainder. Well, it's equal to the remainder when this is c being divided into this. So whatever you get out in the remainder, that is f of negative 1. So 1, negative 3, 2, and 8. Coefficient of that is 1. So bring down, multiply, add, multiply, add, multiply, add. So what is f of negative 1? It's 2. F of c is equal to r. So this is the c, this is the number, this is the 0. So put the 0 in there, and then whatever you get for remainder is what you get when you have that value. Okay? Now, do it the old-fashioned way. Just straight substitution. You can put negative 1 here, 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 and I just want to do that. You don't have to do this. I just want to show you that this is going to equal 2. A negative multiplied together an even number of times is positive 1. That'd be a negative times a negative is a positive. So this is 4. This is 4 minus 2 is 2. Now something's wrong here. Oh, I forgot something. It's a good check. It's good. The f of negative 1 is actually going to be 10. So look at that and see what I did wrong. It's up here. What I forgot is I forgot to put my x squared term in there, so I should put a 0 right in here. So let's try that again, okay? Wish I meant to do that on purpose, but I didn't. So let's try one more time. So 1, negative 3, 0, 2, 8. And now the remainder should be 10. So bring down, multiply, add, multiply, add, multiply, add, multiply, add. So that's using synthetic division to find a functional value. The remainder theorem. F of C is equal to the R, and that's again implying that we're getting a remainder when we're dividing that C into your polynomial. Okay? So, let's call that good. Good luck. Do your work.